So towards the end of the workshop, I discussed with some people what it means to have symmetric and antisymmetric modes in these whispering gallery systems, and it's not at all obvious what that means. One way to try and make it clearer is to do an animation. So I've made an animation with Mathematica. I'll just explain what the parameters up here are first of all. I've got a time toggle here, so this allows the waves to propagate, and you can see we've got a blue wave propagating clockwise and the orange wave propagating anti-clockwise. So these are the two different directions of oscillation that the field can have in the system. I've got a toggle here that switches between this antisymmetric and symmetric superposition of these modes. So that's whether we're taking clockwise plus anti-clockwise or clockwise minus anti-clockwise. I'll come back to the offset in a second. I've got a show toggle here that can show us the standing wave, that is the sum of the clockwise and anti-clockwise modes, so I can turn that on and off. And finally I've got a toggle here for M, which is the number of peaks that I have in my system. So I'm just going to leave that fairly low, otherwise it doesn't plot very nicely. So I can see, what have I got there? 15. Okay, I'll just make that 11 because that seems like a nice number to make everything work. Okay, now first of all, let's look at the behavior of the clockwise and anti-clockwise modes for the toggle, whether I choose symmetric or antisymmetric. So here I've got the blue one doesn't change. I'm just changing the orange one, which is the anti-clockwise mode. I'm either going to have that with a positive sign or a negative sign. And then when I add them together, I'm going to get different superpositions. So there it is with a negative sign, there it is with a positive sign. So I can see that how that works. And then I've got the sum of these two waves. So this is now just adding up the electric field from the blue one and the orange one. And when they're like this, there's nothing because they're all out of phase. But as time progresses, you can see you have a standing wave. And you can see the nodes and the antinodes of the standing wave are sort of positions around the circle. Now, if I change from antisymmetric to symmetric, the position of those nodes and antinodes shift. So there's a different sort of angle for each of those nodes and antinodes. It's sort of been offset by a little bit. If I go to somewhere halfway up and switch between symmetric and antisymmetric, you can see it sort of shifts by a quarter of a wavelength there. All right. Now to really see what it means to be symmetric or antisymmetric, the best thing to do is use this offset. So I can just shift these two plots away from each other, just as a way of visualizing, and then we can look at the behavior. So at the moment I'm set on antisymmetric, and you can see in the middle here, the blue line is propagating clockwise, orange anti-clockwise, and in the middle here they're both moving in the same direction because I've offset them, and they're both moving downwards, and you can see that the blue and the orange are out of phase here in this antisymmetric case, where the orange is the negative of the blue. If I make the orange the same as the blue, then they are in phase. So this is the symmetric mode, and it's symmetric in the sense that when I shift these two away from each other and then look at a place where the wave is propagating in the same direction, because I'm looking at the right-hand side of one ring and the left-hand side of the other, then I have a case where these two things are propagating in phase. The antisymmetric mode, on the other hand, I have the blue and the orange out of phase in this situation here. So this is probably the easiest way to define symmetric and antisymmetric, and you can really see that by flicking this switch going between the symmetric and antisymmetric modes, I have a different standing wave because the standing wave has shifted in position around the ring, and I have a different situation for the relative phase of the blue and the counterclockwise and anti-clockwise light, and that's best seen when you sort of shift these two things off each other.